Okay, so the weightlifting coach claims that weightlifters can increase their strength by taking a certain supplement. To test the claim, the coach randomly selects 9 athletes and gives them a baseline strength test, yada, yada, yada. Tests the claim that the bench press weights using the supplement is greater. So basically, our null is going to be that the means are the same. Oops. And we're trying to show that the means after were greater than the means before. Okay, so the thing to remember here is that these pieces of data are not independent because this is the same guy, this is the same guy, this is the same guy, and so on and so forth. So if they were independent data values, independent things we were comparing, this would be a 2-sample t-test. But since it's not, we're just going to use a regular t-test. And the kind of the giveaways here, they give us this A minus B here, all right? So basically, if these things were the same, if the averages were the same, that would mean that A minus B would be, the average would be 0. The average difference would be 0. If I added up all these differences, I would just get 0 because they're basically the same thing. So if the second one was larger, this is A minus B. So then we would say A minus B. If this is obviously B before and after. So we do after minus before. That should be greater than 0 because after is going to be bigger. Okay. So we're going to use just a regular t-test, but before I do that, I'm going to put my data values into my L1. Okay, so I'm going to hit stat, calculate. I'm sorry, stat test. I'm going to do a t-test. Now my null mu, we're going to say is 0 because basically we're talking about if they're the same. Here's what we'll do it this way. Let me erase this so I can write this so it makes a little more sense. So we'll let if they're equal, that's the same thing as saying mu 2 minus mu 1 equals 0. Or the average of this guy. So let's just do it that way. I'm just trying to make it as clear as possible. So we'll average up the differences, okay? So the average of the differences, if they're the same, would be 0. But we're trying to show if the differences in A and B, if A is larger, then the average differences would be, greater than 0. Okay, we're going to add these up. We'll call that mu. So we're saying it's 0, frequency 1, and we're trying to show that mu is greater than 0. And we will calculate. So we get a p-value of 0.0306. Compared to 0.05, this is less than alpha. So we reject HO. Oh, excuse me. So there is sufficient evidence to show the average weight, you can word this better, after supplement was higher.